Hey, this is Jake White, and this is my CS 2316 final project. I did my project on country health statistics and COVID-19. Introduction. In this project, I found and analyzed data about country health statistics and COVID-19. The goal of this project is to analyze patterns, trends, and relationships surrounding global health and the COVID-19 pandemic to better understand what areas were disproportionately affected and how to better prepare for future pandemics. Dataset selection. I found the dataset selection process to be quite difficult, particularly finding reliable and useful data on health statistics that were free. I was able to find a lot of large aggregated datasets, but they were locked behind a paywall. So finding free datasets proved to be very difficult. On the contrary, finding data on COVID-19 was extremely easy, as COVID-19 data is readily available in many different formats on the internet. I scraped life expectancy data from an HTML page, I got COVID-19 data through an API, and I found a large aggregated CSV file on health statistics that provided lots of detail and was definitely the best source I could find, and definitely the best source out of the three if I were to rate them. So here's dataset cleaning. So on the first dataset cleaning for data parser, you can see where I remove the date range 1971 to 2010 so that I only get the range from 2010 to 2019. And I use iteritems for this. After that, I drop a lot of columns that were not important to the data set. And then I use iterrows to iterate through the rows and indexes to specifically only get immunization data out of all of the data that was there. And trust me, there was a lot. So for the next dataset cleaning for Web Parser 1, this was the HTML page. I used Beautiful Soup to find all of the tags, and I deleted data at the beginning and the end. Yeah, that's about it for that one. So on the third one, this is Web Parser 2. This is the API. So for the API, what I did is I went and found each statistic individually and then appended that onto a list and used a for loop to get all of it for each. And then I made a data frame using a NumPy array of zeros and then used a loc to plug in all of the data into the data frame. So here is insight 1. For this insight, I combined COVID mortality rate and immunization rate. I thought these two stats would be negatively correlated. So I thought, as immunization goes up, COVID mortality rate should go down. I was wrong, as you will see. But in the code, you can see where I iterated through 2010 and 2019, and I deleted all of the columns except for the 2019 data. I dropped a bunch more columns, and I merged the COVID mortality rate and the immunization rate data. So here's insight 2. For insight 2, I subtracted the 2019 immunization rate from the 2010 rate to find the difference for each country. My thought process for this one was that, I already have the most recent 2019 immunization rate, but what might be more important or more pertinent to how the country deals with COVID might be how they're changing as far as their health system. Are they getting better or are they doing worse? And the statistic is some form or measure of that. As for the actual coding, you can see where I drop some columns and then I drop all the columns except for the 2010 and the 2019. I use iteros to drop some more irrelevant data. And then I concatenate the immunization data with the data frame to get the data that I wanted. So here's Insight 3. For Insight 3, I grouped the countries by continent or region and found the total cases, average incident rate, and average mortality rate. So my thinking behind this was I wanted to group the countries together to get kind of a snapshot of how the world is doing in more broader terms and in larger regions. You can see in the code where I list all the countries that are in each continent, and then I use iteros to iterate through the rows and assign all the countries their specific regions, and then group by their regions, and then use aggregate to get the sum, mean, and mean of the data that I was looking for. Here's Insight 4. So Insight 4 compares life expectancy with COVID deaths. I expected there to be a negative relationship between these two variables. Again, I was wrong, and you'll see that later. As for the actual code, it wasn't really too in-depth. I just dropped a lot of columns, and then I merged the life expectancy with the COVID death. Here's Insight 5. So Insight 5 finds the best performing country in each of the specific statistics that I was measuring, including ties. So you would think that Insight 5 would be pretty easy, but then you look at the code and yeah, it's pretty difficult. That's just because making a data frame including ties just made it a lot more complicated, but I was able to do it with a lot of iteros. So here's Visual 1. This compares the immunization rate and the COVID mortality rate. I expected a negative correlation, and this one, there's really no correlation. You can't really draw any conclusions from it, maybe slightly positive, but I would not say that. I would say there's no correlation for this one. So here's Visual 2. So Visual 2 compares life expectancy and COVID deaths. And this one, there's definitely a positive correlation you can clearly see with the line of best fit. And this actually kind of makes sense if you think about it. The older a population, the more susceptible they are going to be to COVID. So here's Visual 3. Visual 3, I am comparing the mortality rate in each of the continents/regions. You can see that in South America, the mortality rate is a lot larger than the other regions. It looks like they did not do that well preparing, whereas Oceania and Europe did a little bit better than the average. And then Africa, North America, and Asia are all about at average. So finally, we reached the results and conclusion. From this project, I learned how to find reliable sources of data from the web and how to get this data. I also learned that analyzing trends in health data reveals a lot of counterintuitive results that should be explored more thoroughly. The hardest part of this project was finding the sources of data in Phase 1. Originally, I was doing my project solely on country health statistics, but after searching through countless sources, I could only find one valid data source. So that's when I switched up my project to include COVID statistics, which were a lot easier to come by. This did mess up a lot of pre-planning I did, which made later sections harder, but I think I was able to rebound. And that concludes this project. I actually enjoyed this project. I learned a lot, and yeah. Thank you for watching.